Hey guys, today we're going to be looking really quickly at molar mass and how to use it as a conversion factor. I know these notes say molar mass and percent composition. We're actually going to do the percent composition tomorrow, so that'll be a different video. Today we're just looking at molar mass. So molar mass is the mass of 1 mole of a substance. Usually we'll be talking about a compound when we do this, though technically elements also have a molar mass. To calculate molar mass of a compound, we're going to use the periodic table and the average atomic masses that are found there. So the steps are written right here. You can read through them or refer to them, but I'm going to be doing the examples down here that follow the steps instead of just reading those off to you. So we're going to look at this first one here, SO3, as an example. SO3 has 2 elements. It's got sulfur and it's got oxygen. So step 1 is drawing a chart. The chart's already drawn for you. Cool. And then we're going to determine the number of each element that is used. So we've got 2 different elements here, sulfur. I'll write down sulfur here under element. And we've got oxygen. You can tell from the subscripts, sulfur doesn't have a subscript, so it only has 1 atom. And oxygen has a little subscript of 3, so it's got 3 atoms. Cool, easy stuff. The average atomic mass of those elements goes here in this next blank, and that's found on the periodic table. So you'll need to whip that baby out. Let's see, I think I have it here in my clip art. I do. There it is, all beautiful. So we were looking at sulfur. Over here, sulfur has an average atomic mass of 32.066. So you'll write down that 32.066 for the average atomic mass of sulfur. And you should put grams with that because these are going to be talking about grams. Then you go look at oxygen. Oxygen is, it's appearing in front of my letters there. Oxygen is 15.999. So we will write that down over here for oxygen. We'll probably end up memorizing that one by the end of this unit. 5.999 grams. So we have 1 sulfur atom that has an average atomic mass of 32.066 grams. What you'll do with those 2 numbers is you'll multiply them to get a total mass for that element. 1 times 32.066 is 32.066, still in grams. And then oxygen has 3 atoms, each with an average atomic mass of 15.999 grams. And you multiply 3 times 15.999 is 47.997 grams. And then you'll add those 2 things up to get the total for the whole compound SO3. Let's see, that's trying to do the maths here. 80.063 grams. So what this essentially means is that if you got 1 mole of SO3, it would have a mass of 80.063 grams. Now let's go try that over here with calcium phosphate. So calcium phosphate has 3 different elements. It's got calcium, it's got phosphorus, and it's got oxygen. We got to figure out how many of each element are in this compound here. Calcium is pretty straightforward. You've just got 3 as its subscript. But PO4 is inside this parentheses with the little 2. The little 2 outside the parentheses gets distributed to each element that's inside the parentheses. So it'll go here with P. So there's 1 P inside the parentheses times the 2 outside the parentheses. So that's a total of 2 phosphoruses. And then oxygen has 4 inside. Sorry, just drew a circle and it was bad. 4 inside multiplied by the 2 that gets distributed for a total of 8 oxygens. And then after you've written down each number of atoms, you go look at the average atomic masses on the periodic table. Let's see what calcium is. Calcium over here is 40.078. We'll write that down. after I make the periodic table small again. 40.078, and that's measured in grams. Then we go look at phosphorus. Phosphorus is 30.974. Write that one down. 30.974. That is grams. Oxygen, we saw previously, was 15.999 grams. But if you didn't remember, you could go find it on your periodic table. Then after you've written down each average atomic mass, you're going to multiply atoms times the mass. 3 times 40.078 is 120.234? Question mark? Yep, pretty sure that's right. And that's in grams. Then we've got phosphorus is 2 times 30.974, which is going to be 61.948 grams. And lastly, we have oxygen. 8 times 15.999 is 127.992 grams. Then you take all those totals, add them together for the entire thing, and you get a total of, let's see, that's 1, 10, 17, 21, carry the 2, 0, carry the 1, 1, carry 1. I think it's 310.174. Yep, that is correct. And that is equal to 1 mole of, once again, I have messed up and done a typo, 1 mole of calcium phosphate. So now you would be able to use that as a conversion factor. All right, so let's do this question as an example. We've got 235 grams of calcium chloride, and we're seeing how many moles that substance is. So we're starting with 234 grams calcium chloride, looking for how many moles. So this first step in converting grams to moles, because that's what we're doing here, is we're going to use molar mass to go from grams to moles, is you draw the chart. Same as we were doing yesterday. Draw the chart, put your given information in the upper left-hand corner, 234 grams of calcium chloride, which is CaCl2. And we're going to see how many moles that represents. To go from grams to moles, you need a conversion factor. Sorry, I just said factor, weird. Factor that says blank grams of CaCl2 equals blank moles of CaCl2. To find this conversion, you need to know the molar mass. So for CaCl2, you've got 2 elements. You've got calcium and you've got chlorine. There is 1 calcium in CaCl2 and 2 chlorines. Then you need the average atomic mass, which will come from the periodic table. Let me find mine in my clip art. There it is. I don't know why it always creates 2 every time I do that. All right, so we've got this chart here to tell us the mass of calcium. Calcium right there is 40.078. So we write that down for calcium, 40.078, and that is in grams. And then chlorine, way over here, is 35.453. 35.453 grams. Now with those 2 numbers, I multiply. 1 times 40.078 is 40.078, still in grams. 2 times 35.453 is 70.906 grams. Then to find the total molar mass, I add those things up, and we get 110 point, let's see, that is 984 grams. That is the molar mass of calcium chloride. And molar mass means that 1 mole calcium chloride is 110.984 grams of calcium chloride. So essentially, finding molar mass is just finding the conversion factor between moles and grams. Now we got to plug this into our handy dandy dimensional analysis chart. We've got grams of calcium chloride on the top, which means we're going to need grams of calcium chloride on the bottom. This thing. We have 110.984 grams of calcium chloride. Sorry, I just did chlorine weird. There it is. Calcium chloride, which was equal to 1 mole. Whatever this bottom thing is equal to goes on the top. 110.984 grams calcium chloride equals 1 mole of calcium chloride. Grams and grams will cancel. We're left in just moles. So you do 234 times 1 divided by 110.984. I can't do that one in my head, so I got to pull out the calculator. 234 times 1 divided by 110.984 gives you 2.108, and that is in moles of calcium chloride. All right. You should have some practice in there going grams to moles. So go work on that. And you might also have some practice just calculating molar mass. All right, guys, we'll catch you later. If you need help, please, as always, let me know. Email me or come to office hours.